Welcome. Today we are looking at hydrocarbons, focusing on alkenes and alkynes. This is a key topic in your chemistry exams for SS2. Pay close attention. Let us begin. First, let me explain what alkenes are. Alkenes are unsaturated hydrocarbons. They contain at least one carbon-carbon double bond. The general formula for alkenes is CnH2n. The simplest alkene is ethene, C2H4. Ethene has two carbon atoms joined by a double bond. Each carbon is also bonded to two hydrogen atoms. The second alkene is propene, C3H6. Propene has three carbon atoms. The double bond is between the first and second carbon atoms. The third alkene is butene, C4H8. Butene has four carbon atoms. There are different isomers of butene. The double bond can be at different positions. The double bond is the functional group of alkenes. It is reactive. Alkenes are more reactive than alkanes. The double bond can be broken. This allows addition reactions. Now let me explain the structure of alkenes. Alkenes have a carbon-carbon double bond. The double bond consists of one sigma bond and one pi bond. The sigma bond is strong. The pi bond is weaker. The pi bond is responsible for the reactivity of alkenes. The carbon atoms in the double bond are sp2 hybridized. They have a trigonal planar geometry. The bond angles are about 120 degrees. The double bond restricts rotation. This leads to geometrical isomerism. Alkenes with different groups on each carbon of the double bond can exist as cis and trans isomers. In cis isomers, the similar groups are on the same side. In trans isomers, the similar groups are on opposite sides. Cis and trans isomers have different physical properties. They have different boiling points and melting points. They also have different chemical reactivities. Geometrical isomerism is an important concept in organic chemistry. Now, let me explain the nomenclature of alkenes. The IUPAC system is used to name alkenes. The name has three parts. The root indicates the number of carbon atoms in the longest chain containing the double bond. The suffix indicates the type of compound. For alkenes, the suffix is Na. The prefix indicates the position of the double bond. The double bond is given the lowest possible number. For example, propene has a double bond between carbon 1 and carbon 2. But 1-ene has a double bond between carbon 1 and carbon 2. But 2-ene has a double bond between carbon 2 and carbon 3. The name also includes the position of substituents. For example, 2-methylprop 1-ene has a propene chain with a methyl group on carbon 2 and a double bond between carbon 1 and carbon 2. The rules for naming alkenes are similar to alkanes. The main difference is the suffix and the position of the double bond. Now let me explain the physical properties of alkenes. Alkenes are similar to alkanes in their physical properties. They are nonpolar molecules. They have weak van der Waals forces. They have low melting and boiling points. The melting and boiling points increase with molecular size. Alkenes are insoluble in water. They are soluble in organic solvents. They are less dense than water. They are colorless and odorless. The first two alkenes are gases. Ethene and propene are gases. Butene and higher alkenes are liquids. The physical properties of alkenes are similar to alkanes. However, alkenes are more reactive. This is due to the double bond. Now let me explain the chemical properties of alkenes. Alkenes are more reactive than alkanes. They undergo addition reactions. In addition reactions, the double bond is broken. New atoms or groups are added to the carbon atoms. The most common addition reactions are hydrogenation, halogenation, hydration, and polymerization. Hydrogenation is the addition of hydrogen. The alkene reacts with hydrogen in the presence of a catalyst. The double bond is broken. The alkane is formed. For example, ethene reacts with hydrogen to form ethane. The reaction is C2H4 plus H2 equals C2H6. Hydrogenation is used in the food industry. It converts unsaturated oils into saturated fats. Halogenation is the addition of halogens. The alkene reacts with a halogen like bromine or chlorine. The double bond is broken. A dihalogenated compound is formed. For example, ethene reacts with bromine to form 1,2-dibromoethane. The reaction is C2H4 plus Br2 equals C2H4Br2. The red-brown color of bromine disappears. This is a test for unsaturation. Hydration is the addition of water. The alkene reacts with water in the presence of an acid catalyst. The double bond is broken. An alcohol is formed. For example, ethene reacts with water to form ethanol. The reaction is C2H4 plus H2O equals C2H5OH. Hydration is used to produce ethanol. Polymerization is the reaction of many small alkene molecules to form a large molecule. The double bond is broken. The monomers join together. The polymer is formed. For example, ethene polymerizes to form polyethylene. The reaction is NC2H4 equals CH2CH2N. Polymerization is used to produce plastics. Now, let me explain the test for unsaturation. The bromine test is used to distinguish between alkanes and alkenes. A few drops of bromine solution are added to the hydrocarbon. If the color of bromine disappears, the hydrocarbon is unsaturated. It contains a double or triple bond. If the color remains, the hydrocarbon is saturated. It contains only single bonds. The reaction is the addition of bromine to the double bond. The red-brown color disappears. This is a simple and reliable test. The bromine test is used in the laboratory to identify alkenes and alkynes. Now let me explain what alkynes are. Alkynes are unsaturated hydrocarbons. They contain at least one carbon-carbon triple bond. The general formula for alkynes is CnH-DV. The simplest alkene is ethene, stva, hadva. Ethine has two carbon atoms joined by a triple bond. Each carbon is bonded to one hydrogen atom. Ethene is also called acetylene. The second alkyne is propyne, C3H4. Propyne has three carbon atoms. The triple bond is between the first and second carbon atoms. The third alkene is butene, 4H. Butene has four carbon atoms. There are different isomers of butene. The triple bond is the functional group of alkynes. It is reactive. Alkynes are more reactive than alkenes. The triple bond consists of one sigma bond and two pi bonds. The pi bonds are weak and reactive. Now let me explain the nomenclature of alkynes. The IUPAC system is used to name alkynes. The name has three parts. The root indicates the number of carbon atoms in the longest chain containing the triple bond. The suffix indicates the type of compound. For alkynes, the suffix is -vine. The prefix indicates the position of the triple bond. The triple bond is given the lowest possible number. For example, propyne has a triple bond between carbon 1 and carbon 2. But 1-ine has a triple bond between carbon 1 and carbon 2. But 2-ene has a triple bond between carbon 2 and carbon 3. The name also includes the position of substituents. For example, 2-methylbut 1-ine has a butyne chain with a methyl group on carbon 2 and a triple bond between carbon 1 and carbon 2. The rules for naming alkynes are similar to alkenes. The main difference is the suffix and the position of the triple bond. Now let me explain the physical properties of alkynes. Alkynes are similar to alkanes and alkenes in their physical properties. They are non-polar molecules. They have weak van der Waals forces. They have low melting and boiling points. The melting and boiling points increase with molecular size. Alkynes are insoluble in water. They are soluble in organic solvents. They are less dense than water. They are colorless and odorless. Ethene is a gas. Higher alkynes are liquids or solids. The physical properties of alkynes are similar to alkenes. However, alkynes are more reactive. This is due to the triple bond. Now, let me explain the chemical properties of alkynes. Alkynes are more reactive than alkenes. They undergo addition reactions. In addition reactions, the triple bond is broken. New atoms or groups are added to the carbon atoms. The most common addition reactions are hydrogenation, halogenation, and hydration. Hydrogenation is the addition of hydrogen. The alkyne reacts with hydrogen in the presence of a catalyst. The triple bond is broken. The alkene or alkane is formed. For example, ethine reacts with hydrogen to form ethene and then ethane. The reaction is C2H2 plus H2 equals C2H4. The reaction is C2H4 plus H2 equals C2H6. Halogenation is the addition of halogens. The alkyne reacts with a halogen like bromine or chlorine. The triple bond is broken. A tetrahalogenated compound is formed. For example, ethine reacts with bromine to form 1,1,2,2 tetrabromoethane. The reaction is C2H2 plus 2Br2 equals C2H2Br4. Hydration is the addition of water. The alkyne reacts with water in the presence of an acid catalyst. The triple bond is broken. An aldehyde or ketone is formed. For example, ethine reacts with water to form ethanol. The reaction is C2H2 plus H2O equals CH3CHO. Hydration of alkynes is an important reaction in organic chemistry. Now let me explain the uses of alkenes and alkynes. Ethane is used to produce ethanol. It is used to produce polyethylene. Polyethylene is used in plastics. Ethane is used to produce ethylene glycol. Ethylene glycol is used as antifreeze. Ethene is used to produce PVC. PVC is used in pipes and cables. Propene is used to produce polypropylene. Polypropylene is used in packaging and textiles. Propene is used to produce acetone and propylene glycol. Ethine is used in welding and cutting. It produces a very hot flame. Ethune is used to produce acetaldehyde. Acetaldehyde is used to produce acetic acid. Ethine is used to produce synthetic rubber. Alkynes are used as starting materials for many other compounds. They are important in the chemical industry. A common exam question asks you to distinguish between alkanes, alkenes, and alkynes. Here is a sample answer. Alkanes are saturated hydrocarbons with single bonds. The general formula is CnH2n plus 2. Alkenes are unsaturated hydrocarbons with double bonds. The general formula is CnH2n. Alkynes are unsaturated hydrocarbons with triple bonds. The general formula is CnH2n2. Alkanes are less reactive. Alkenes and alkynes are more reactive. The bromine test distinguishes alkenes and alkynes from alkanes. Another exam question asks you to describe an addition reaction of an alkene. Here is your answer. Alkenes undergo addition reactions. The double bond is broken. New atoms are added. Hydrogenation adds hydrogen. Halogenation adds halogens. Hydration adds water. Polymerization joins many molecules. For example, ethene reacts with bromine to form 1,2-dibromoethane. The double bond is broken. The bromine atoms are added. The red-brown color of bromine disappears. This is the bromine test for unsaturation. Another exam question asks you to explain the uses of ethene and ethene. Here is your answer. Ethene is used to produce ethanol, polyethylene, ethylene glycol, and PVC. Ethine is used in welding and cutting. It produces a very hot flame. Ethine is used to produce acetaldehyde and acetic acid. Ethene and ethene are important starting materials in the chemical industry. Let me give you a quick summary. Alkenes are unsaturated hydrocarbons with double bonds. The general formula is CnH2n. They undergo addition reactions. Hydrogenation, halogenation, hydration, and polymerization are important reactions. Alkynes are unsaturated hydrocarbons with triple bonds. The general formula is CnH2n2. They are more reactive than alkenes. They undergo addition reactions. The bromine test distinguishes unsaturated hydrocarbons from saturated ones. Alkenes and alkynes have many uses in industry. Practice these concepts. When you have them down, move to topic 9.